All right. Hello, everybody. This is the Network Plumbing Working Group meeting for September 27th, 2018. And the first item on the agenda is Peter. They have a demo using Multis, and they would like to show this demo and talk about it. So before we kick it off to Peter, if anybody else has things they'd like to talk about, please put that onto the agenda doc and we'll get to them after the demo. Otherwise, we will end the meeting first. So over to you, Peter.
Okay, so what we have, it's not so much a demo, is I'm going to tell you a little bit about what we did. We thought about showing a demo, but it'd be an awful lot of screenshots of containers running and stuff that wouldn't tell you very much. So let me share screen. I've got a couple of slides. I think there's about 5 slides in total that just talk through what we did. So let me do that screen share. And you should hopefully now be able to see.
Yep, we can see.
A couple of slides. Okay, so background to this, obviously you guys have been doing a great deal of work in putting together multi-network capability for Kubernetes. And we've been interested in that from the point of view of what we're selling to customers and what we're prospectively selling to customers. And we've now done some work where we actually took what we've got out of this group. So that's the Multis reference plugin and so on, and the spec, and applied that to a real telco app, ran it in a Kubernetes cluster, and got some interesting, discovered some interesting things from that. So let me talk you through what we did and what we found. So firstly, a little bit of background about what we're doing here and why we're interested. So we're running telco apps here, and by telco apps, that's mostly telephony, but it's also network management apps. And there's a whole bunch of multiple network requirements here that come from various different customers. All of our customers are different, and they all have slightly different requirements, but there's a whole bunch of motivations. I'm not going to read you through them all, but typically the 2 key things to think about are many of our customers are tying together, many of our customers are telcos or service providers who are tying together the networks of multiple other customers, and so they've got literal different physical networks, and they are the junction point between them, and so they are acting as a session border controller, or sometimes as a firewall in telephony, a little bit more telephony specific than that, than just a straight firewall, but they're between networks and doing function that relies on them having access to networks. And then there are all kinds of security and regulatory requirements, which I won't bore you with, to do with different things needing to be on different networks and so on. So we have a bunch of applications that we are already selling to people, that we're selling in VMs largely, and we've been looking at running them in containers, and the networking thing has been a handicap to being able to run them and sell them in containers. So we took in multi-network stuff and we wanted to apply them to some applications. I'll talk a little bit more about what the application does and how it fits together in a moment. I'll mention source-based routing, though, because source-based routing is an interesting thing that we realized was not available from the multi-network group so far. And the idea of source-based routing is that if you're given an IP address to send traffic to, it's only the application that knows whether it wants to send SIP, and therefore it goes out over the signaling network, or media, and it goes out over the media network, or some database access, and it goes out to some different destination. And so in order to make that routing work, we generally have source-based routing in our VMs. And we didn't know of a way of doing that in containers, but it turned out to be fairly simple to do that with the CNI plugin, which I'll come to in a minute.
So, Peter, just a question, like, how do you know the other hops in the source route? Like, do you have some other out-of-band mechanism by which you figure out, like, where the next hops are in the container?
So generally, there will be a default route and some gateway on each network, and we just send that default route, and that's good enough. But you can have multiple default routes, one for each interface, so long as you're using source-based routing, because you're in a different routing table for each interface.
Okay. No, I was thinking of it more in the service chaining context, like where you have to know the addresses of the next hops in your service chain pretty much, right? Since you said telco. So maybe
sure.
I'm not looking too fast. Yeah.
So for the most part, we've not been thinking about service chaining. We're thinking largely about telephony applications. I suspect we're going to find more interesting edge cases as we get into more and more complicated applications. But we haven't thought about that use case yet.
Okay, perfect. Thank you.
So the other thing I'll mention is we thought about doing a demo that involved fast networking, SRIOV, DPDK, all the rest of it. We haven't done that. That's primarily because that is more complex and difficult to set up, and we wanted to go for a good use case. that would be quick and easy to set up. So here's a network diagram. This is a bit schematic. There's a lot more pieces in the picture than this, but once you've seen this, you kind of understand what we're getting at. The black line is the management network. That is a network that is not exposed to the internet in any way. It's purely internal. And then there are red and blue lines for the signaling and media network. TUI, I put that up thinking, of course, everyone knows what a TUI is, but of course, nobody does unless you work in the telco space. TUI is telephone user interface. So that's the thing that actually manages signaling for phone calls, and the media server is actually playing audio and phone calls. And on the left, we have the internet. There's a whole bunch more pieces in the actual product that we're running, which is MVM, mobile voicemail. But that picture gives you the flavor of a whole bunch of different components on a network, and a couple of them need access to in our case, a second network. We put signaling and media together for purposes of the demo. So that's enough of what we're trying to achieve and what we wanted to demo and what kind of capabilities we wanted to show off. Here's a little bit about how we did it. So we took MVM, as I just said, mobile voicemail, as a case study, as a nice, easy application with fairly well-contained requirements. We were running in Kubernetes and Azure. We're actually using the standard Azure Kubernetes service, but with the networking replaced by some careful use of daemon sets. We used the Multis plugin with network attachment definitions, all according to the spec, and we had a file management network, and we used the Azure network for telephony. So that's all fairly straightforward. And then a couple of interesting things that came out of this. I mentioned source-based routing. In order to get source-based routing to work, we wrote a CNI plugin. It's not a very complicated CNI plugin. It's tens of lines of code, I think, rather than hundreds.
So where is the actual routing happening? In the kernel or the application right now? So
the source-based routing. The way source-based routing works is that, let's imagine the application wants to send a SIP message, so a message that is going out as a signaling message. There are two parts of that. The first part is the application needs to decide before it starts sending out UDP packets to bind to the correct address on the correct interface. And of course, it knows that this is signaling because, well, it's the application doing signaling. It knows it's trying to send out SIP. So it's configured to bind to the correct address. The second part of that is that the correct IP rules and IP routes must be set up so that traffic from that address goes into the correct routing table, and the routing table has the correct rule set up in it. So the first part is just done in the application. The second part is set up in advance by the CNI plugin, and this CNI plugin is a chain CNI plugin that runs after.
So you're basically running VRFs under the one with different routing tables per interface. Is that what it is? No, okay, source route.
Yeah, so it's a different routing table, one per interface. Yeah. So fairly straightforward. In technical terms, we used Helm to install everything. I'm a big fan of Helm. It makes everything much, much better and easier. So we both installed all the networking daemon sets using Helm. I think it's rather amusing that you can run Helm on a running Kubernetes cluster and blow away its entire networking infrastructure and replace it without anything going wrong, but that seems to be the case. We also used Helm to install our application, so we've got Helm charts for our application. We already had those. We just added the ability to have multiple networks in them. And the last little technical thing to mention is we had to get those IP addresses into the container, so the container knew what its IP address was. And the way we did that was it was reading an environment variable. We had an init container that would read the annotation out of the pod and effectively write it into environment variables by way of a little bit of plumbing of files. So that was pretty straightforward. Like I say, I'm not going to actually do a demo and show you stuff running because it'll just be a lot of me typing commands and you seeing stuff go past on the screen, but I think I've described it in enough detail. Let's talk about what we actually found. So the conclusions, I was expecting it to be much harder than it was. It worked very, very quickly. Everything just worked. I found precisely 0 bugs outside my own code. So that was all good. It was really nice and quick. A couple of interesting things I did find. One is, surprising to me, number of CNI plugins only support a single instance. So Azure, the AWS VPC plugin, Flannel, they all have baked into them to some greater or lesser degree the idea that there's only a single CNI plugin deployed on the box. I guess maybe that's not that surprising. People have not run CNI plugins for multiple interfaces much before. But if you, for example, are running the Azure CNI plugin for one network, you can't have the Azure CNI plugin connected to one interface to 2 different interfaces on 2 different networks and have 2 instances running. They just get in each other's way, and the configuration gets very confused. It's possible as a way of setting it up, but I never worked it out. So there's one of the conclusions I came away with was, in order to work with a lot of the existing CNI plugins out there, either the CNI plugins are going to have to change, or we'll have to be very clever with configuration or something. The third thing is something that I know everyone's aware of, which is it was a bit of a nuisance not being able to do DNS lookups and have services. So when you create a bunch of instances and they're on the signaling network, it'd be nice to have a service that at least allows you to DNS lookup and see what all those IP addresses are. We had to do that manually by effectively putting those IP addresses into a service via the endpoints API. So it's a little bit tedious. I know that Kural, I think, was putting out a document about resolving this, and there's been some discussions, but that'll be a good thing to have. And the final thing, as a conclusion, is source-based routing CNI plugin. So we've written a CNI plugin that does source-based routing, and we're looking to open source it. We don't want to be an internal thing that only we use. We'd like to open source it and put it somewhere. We're still figuring out how to do that, and we'd like to hopefully find a good place to put it on the web, ideally with other plugins. Possibly with other CNI plugins if we can get the CNI maintainers to agree to that, although I haven't asked them yet, but maybe somewhere else, we're not sure. But I think the meta conclusion on top of all that is we needed to run with multiple networks. We got multiple networks working. This is a real application. It's running in a real cloud, and you can make phone calls to it, and it is using multiple networks, which was very positive. So I was extremely pleased at how quickly the whole thing came together. It took us, I think, less than a week to get everything up and running and working, including all the figuring out how things work and writing the CNI plugin as part of that. So that was all good news. And I think that's it. I think I'm done. Any questions?
That's awesome. Thank you, Peter. Yeah, I had a question around Multis and the network CRDs and things like that. What were your experiences with that? Did you run into any issues? I guess, as perhaps one of the first more productized uses of the stuff that we've been working on here, what did you find? Were there any kind of rough edges with that? How are you creating those CRD objects and that kind of thing?
Sure. So we're creating them with Helm charts. And the way we created the Helm charts was I just handcrafted the YAML files and put the JSON config into there. The biggest problem I came across was I kept missing commas out. And I cannot blame Multis for me being unable to remember to put all the commas into JSON, which I wrote by hand. But apart from that, I found absolutely no bugs. It just all worked, which was extremely gratifying. It just all worked straight out the box, and it seemed very straightforward to do. So I was expecting to find more things wrong than I found, and it just all worked very smoothly. So no, it was great. So well done to all the people who did the work on this, because it really just worked.
Do you think that the admission controller that Kural and his team have written, and I think is available out there, might help with the syntax issue? It's at least meant to do admission control on the objects and perhaps point out syntax errors in the JSON a lot earlier than it would get down to Multis, for example.
Yeah, I think that would be good, actually, because the biggest error I found was definitely silly little JSON errors. You go and you set something up, and then it fails, and then it's a pretty obvious error because things stop working quite dramatically. But the one problem is once you've done something as fundamentally as broken all the networking, it's not all that easy to diagnose that because things start falling over in quite complicated ways. So yes, I think that probably would be useful.
Okay.
We got away without it. I got more careful with commas as time went on, frankly, but. Yeah, so I think, and if there was something that could somehow, this is probably totally impossible and impractical. Checking that it's valid JSON would be very good, but the second level would be checking that it's valid JSON that's consistent with whatever the particular network plugin requires, and that second bit is almost certainly impossible in practice.
Right.
Because there's so many different plugins in there. They all require different stuff.
Right. Well, that's great. Thank you. Does anybody else have questions or comments for Peter?
Yeah, I have around. So right now, the routing rules then basically goes in, call it sideband, or they have to be known ahead, right? And it's not communicated through any sort of Kubernetes configuration method. How do you see that? I mean, I can't really see us using annotations to set up the routing rules. They're probably much more dynamic than that, right?
So the routing that we were using was very basic in that the routing the routing came in through the CNI plugin config. So the particular way that we did a mixture of flannel, and the flannel routing rules are very trivial, in that flannel really just says send it all the traffic out through this one IP address and let something else deal with it. However, you could add more routes to the flannel config for the default network. So that way you can get network config and you put them in through network attachment definitions. And that was flexible enough for us. The way that the source-based routing plugin worked with the routing and in terms of putting them into separate tables was it would effectively come along after the ordinary plugin had set its routes up. The routes for that ordinary plugin would be set to send traffic to some particular interface. It would take all of those, just move them into a separate table. So the assumption was you set all your routes up once through the ordinary CNI plugin by passing them in through the network attachment definition, and then the source-based routing plugin kind of goes and moves them into a separate table. That might not be bomb-proof in every case, but it was good enough for the case that we were doing.
Okay, thanks.
I should say, if anyone's interested, the source-based routing, the actual code for that, we're going to make that public in due course. We have to jump through some hoops before we can do that. And we also, I've got the Helm charts if people are interested in seeing them for how we set up the network attachment definitions and install the daemon sets and so on. So we could share those as well.
All right, any other questions for Peter? If not, we have no more agenda items. Is there anything that anybody wanted to talk about that is not on the agenda?
Well, I just wanted to say that I'm sorry that I've been away for so long, but so we go in GA next week, and it's just been like living in a hole in the last couple of months. So,
yeah, fair enough.
Sorry for that.
Hey, Dan, I had a question. Is there any plans to move the CNI up to 070 for Kubernetes? And do you know what the plans are?
Yeah, so currently we are working on some changes for the spec. Those changes have been committed, and now we're working on getting those changes into the plugins. Basically, there were some persistent problems with the get action, which I've probably talked about in the past with at least some of you on the call. And so we ended up changing that get action into a check action, which preserves the ability of plugins to report errors in the container network, which was one of the two big things with get. So instead of mixing the report errors from the container and the plugin and trying to reconstruct the result, which was the two goals of get, we changed the spec, and the spec is not released, so this change will be part of the 04 version of the, or 05 version of the CNI spec, 04, sorry. It is now broken into a check action that plugins can implement that will report those errors, and then some additional code in libcni, which is kind of like the driver that runtimes like Kubernetes would use to cache the results on disk that then the runtime could just call and get that result back out. And the main goal of that is to make it so that Kubernetes does not have to jump into the container itself and run like nsenter or enter the namespace and always look for ETH0 and then pull the IP address out. It's really meant to provide all the information that the plugin originally sent back to Kubernetes in a way that Kubernetes doesn't have to add more code and add that. So those are the ideas with that. And so now that we've got the spec part there, we are converting the plugins over to support this, and it should be pretty easy because the caching part's already been done for a while. It's just moving the plugins from some of the get implementation we had into check. But that's kind of a net code loss, and we expect that to go fairly quickly.
Okay.
Well, this doesn't give you a hard date for when the CNI spec 04 will come out and the plugins version 07, which implements spec 04.
Yeah.
It should be a matter of weeks to maybe at most like a month, I think.
Oh, cool.
So
cool. Thanks.
Yep. And we've got some additional resources at Red Hat that we've been able to put to work on some of this. So hopefully that will move things along upstream.
Awesome. Thanks.
So, yep. And then of course the other side to this is a PR to actually use some of this functionality in Kubernetes. But I don't think that would be too awful. First off, that would be updating the Docker shim CNI driver, but then also we probably want to update the Cryo OCI CNI driver as well. So there you go.
So then one more thing. So we're going EA now. I think Suresh and I will bring in Abdallah. We would really like to demo what we've done. So the inside, not sort of the inside of the control cluster where we actually on the fly add networks to routers and set all that stuff up. Could be fun to do.
Okay.
Like or something like that.
Yeah, sure.
Whenever we have time, it's more up to you to decide. So,
okay.
I would say 2 meetings from now, Dan, would be like.
Yeah, that's probably good. Then we have the official launch as well.
Yeah.
Okay, so you're thinking of, for example, October 25th or thereabouts, maybe?
Exactly. Yeah.
Something like that. Yes, exactly.
Okay. Yeah, sure. I think that would be fine. I'll add a note to the agenda. And let's see.
And and like we said, we have promised to open source everything. We're working now. We'll start now sort of to tear things apart, because when we did it the first time, everything is sort of stuck together. But we'll separate out the different layers so that it can be added to Multus, what we have done.
So right now it's tangled with our deployment stuff, so we're trying to untangle it so we can separate out the just everybody's interesting pieces and ours.
Okay.
Hey, another side note, Dan, I didn't know the process for this, but I took an action item to do the consistent interface naming. So I did put a description in the document, okay? So it's a longer description. So whenever you want to handle it, we can actually take a look at it maybe next week, because I don't know Mike is on the call, but he wanted to take a look at it because he was the one asking for more details, but I did put it in.
Okay, excellent. Thank you very much. Yeah, let's take a look at that on the October 11th meeting.
Okay, excellent.
So, and then I put you guys in the calendar for a demo on the 25th.
Excellent. Sounds good.
So,
I assume everyone will be in Seattle, right, in December, so we should set aside some time to meet up there as well.
Yep. Yeah, definitely. We should try to make that happen. I can look into if there's some specific time slots or something like that, or if we can get a room. Otherwise, we can just do it impromptu somewhere.
Yeah, go out and have dinner some evening or something like that.
Yep.
Yeah,
or
I
that.
signed that up for the meetup in the Google Doc without him knowing, but yeah.
Right. All right. Anybody else have anything? Going once, going twice.
Have a nice weekend, guys.
Yep.
You guys take care.
Take care, everybody.
Bye.
Thanks. Bye.
Bye.
Bye now.